Yes.
Yes, sir.
So as we
Yes,
know,
sir.
isotopes. So isotopes means in the sense of what? Same thing you have to remember. Isotopes means same atomic number, but different. Same atomic number, but what it is? Different
Different mass number.
mass number. So this mass number only varies because of whom? Only varies number of
Neutron.
understanding. So number
Of
of
neutrons.
neutrons only. So the neutrons only will decide either the mass number or we can say atomic mass increases or decreases by only depends on the number of neutrons. So different kind of examples of isotopes we have been studied in the last class, including the percentage calculations also. So how to find atomic mass or average atomic mass of isotopes if you notice it. So the average atomic mass of isotopes if you see, what is the formula we can say? Atomic mass of first isotope, yes or no? First isotope into abundance of percentage of abundance, yes or no guys? Plus next one, atomic mass of second isotope into percentage of abundance plus so on. It is used to continue. So now in last class we have been calculated for chlorine. So chlorine average atomic mass is how much? 35.5. How we have been found? So we have two isotopes of chlorine. One is chlorine 1735 and next one is chlorine 1737. Chlorine 1375 is present 75% in the chlorine total, and chlorine 1737 is present 25%. So we have been found that how 35 into 75% plus next one is what? 37 into 25%. So if we solve this one, we is to get averagely 35.5 U. This is what? Average atomic mass of chlorine. Is it yes or no? You ever seen like that? So even yesterday, I taught you one example also. Next one, calculating barium. Yes or no, guys? A barium isotope. So we have been got
Bromine, sir.
so bromine isotope. As we know, bromine isotope, what is atomic mass you got? Bromine. Bromine, we used to got
80.
so that is what. And also later we have been found one more question, finding the percentage of abundance of X isotope, which is containing X816 and X818. Do you remember? We have been found the percentage of some X unknown element, 816 and 818. So if you don't know unknown thing, what we have to assume? The percentage of abundance, if you don't know, what we have to assume, guys? We have to assume
X, sir.
X minus.
the first isotope is X means, as we know, total percentage is how much? Total percentage is 100. So if first isotope is X means the second isotope is what? 100. So this is what we have to assume, second isotope, and we have to proceed. So like that only we have to find, if they will ask you to find the abundance. In your exam, I am saying you listen now PT3, definitely either calculating the average atomic mass or calculating the percentage, one question surely will be there in exam. Everybody's, every school, including your school, Jayavarsni or Shakti or whatever normal, our school, everybody's, this one question surely it will come. And Pradosh called to Darunra. So that is what you have to remember. So calculating average atomic mass or percentage of abundance, everybody should practice. In exercise, you have a similar question. I think this is the exercise question. Yes, sir? Elvoken?
Yes, sir. Yes, sir.
That is. So three questions totally. One is bromine, another one is chlorine, and now we are saying for calculating abundance of X, that element also we know. What is that element? That is only oxygen. Yes or no? So be everybody practice it. Okay, Samayan Manya, you understand? Adarshan, this question surely it will come. So now if we'll take it very carefully, and same way if we'll take hydrogen. So hydrogen, we are having a three isotopes for hydrogen. So what is that? First one is hydrogen. What? Hydrogen 1,1. Next one, hydrogen 1,2. Hydrogen 1,3. So now hydrogen 1,1 we used to call it as what? Light hydrogen. Light hydrogen, which we used to call it as what? Protium.
Protium.
So which is called as protium, and the second one, middle one, we used to called as what? It is called as
Deuterium.
deuterium, and the third one is called as tritium. Yes or no? This is tritium is only called as, this is heavy. Second one is called as heavy hydrogen, and third one is called as very heavy hydrogen. Very heavy hydrogen. So who is varying here? Number of protons are 1. Here also number of protons are 1. Here also number of protons are 1. But here number of neutrons are how many? Other side, neutrons are 0. Here number of neutrons are 1. And here number of neutrons are 2. So that is why the total atomic mass. Here what is atomic mass? Here atomic mass is 3U. And here atomic mass is 2U, and here atomic mass is what? 1U. So that is why we can say this is called as light hydrogen is known as protium, and a very heavy hydrogen is called as what, guys? We used to call it as tritium. So in exam might be having a question, they may be asked you, write the 3 isotopes of hydrogen and explain with the structures. So by that time you have to draw the structures also. Understand? So everybody have to write. So one is protium, another one is deuterium, and third one is tritium. So how to draw the structures? Yesterday I have shown you the picture. Do you remember? So we have to draw a first hydrogen, only 1 proton, and how many electrons, guys? 1 electron. So this is protium. Next one is what? 1 proton plus 1 neutron. 1 electron will be deuterium. Next, third structure what? 1 proton plus how many neutrons, guys? 2 neutrons. 1 electron will be inside. So that is what we used to call as tritium. Atomic mass is 3U. So like that, neatly you have to explain it. So like that, other isotopes examples also I told you. For example, carbon, if you take carbon, what is atomic number? What is atomic number of carbon? 6. So carbon 12 and carbon 13 and carbon 614. These are the 3 isotopes of carbon. Yes or no? Yes, that is. Yes, Ma Aswita and Shruti is there. Ma, please call them. That also. Hey boys, all are there. Monish joined.
Sir, Darun not picking phones.
Darun joined already. Darun joined. Only now Shruti and as well as Aswita. Mani and Samya informed to Shruti, Aswita. So now, same way as I told you, one more example. Oxygen. What is the isotopes of oxygen? Anybody? Isotopes of oxygen, please. Isotopes of oxygen is also 3. What is that? Oxygen
and O6.
16, oxygen 817, and oxygen 8. These are the isotopes of oxygen. Same way, if we'll take next, one of the noble gas also I told you. What is a noble gas isotope? Tamil Selva?
Neon.
Okay. So neon what? 10? How much, guys? 10, 20, and 10. Yes,
21.
10, 20, 21, and 10, 20, 20. Yes, my friend. Are you doing or not? So this is what isotopes you have been studied in the last class. And as I told you, all the isotopes having similar characteristics. Which characteristics? All the isotopes, they will show similar chemical characteristics. So chemical properties are same, but whose properties are changing? Chemical properties same for isotope, all isotopes, but who is changing, guys? Physical properties. Physical properties. Because chemical properties is involving whomra. Anybody can say it is based upon what? Jayavashini? Chemical properties is based upon electronic configuration. So physical properties is based upon what? Atomic mass, understanding, or mass number. So they are not same. So what is the examples of physical properties? Laksha, what are the examples of physical properties? Density,
melting point, boiling
point, etc. So these are only called as physical properties. So if we take all the isotopes of any element, chemical properties are same, but physical properties are not same. Clear, Sai? Yes?
Yes, sir.
So now, this if you'll understand this, then as I told you, three questions already we solved. That is what? Average atomic mass of chlorine. Next one, average atomic mass of bromine, and as well as calculating percentage of X element. Yes or no, guys? Now, in our today's class, we are going to study. This is a new thing for you people. That is what? Radioactive isotopes. Please, all of you keep heading. Radioactive isotopes. Isotopes. So you might be watched a movie called as Robo 2, Akshay Kumar and Rajinikanth. Have you watched it, guys?
Yes,
Yes,
sir.
sir.
That something is happening. The movie theme itself, you might be noticing because of cell phone signals and as well as the cell phone towers. So many lower organisms like simple organisms like small birds, sparrows and all, they are going to extend. That is what against to this radiations only, heat only, that movie. Yes or no? Because of cell phone towers and all, they are causing a special kind of heat waves which is destroying the environment. Means like a small organisms like crows, sparrows, understanding this all is going to extend. That is what the movie is related to that. Yes, guys? Yes?
Yes, sir.
That is only, let us comes to here, understand, you might be heard every time, radiation. This generation, 21st generation, the most important word which we'll use every day is radiation, always. Yes, Adarsan? So now, what do you mean by this radiation and how these radioactive elements and what is the importance of this radioactive isotopes? That is all we'll study now. So for example, remember, radiation means it is the one form of heat only. What do you mean by radiation? Heat, it's just a heat. But all the heat energies is not helpful for our body. Some may causes some problem. That is what we used to call as, which will damage our bodies or will destroy the environment, is called as radiation. Understand? Or else that elements we used to say radioactive elements. So now let us see. We can say we are having two kinds of isotopes. Basically here, these radioactive isotopes are two types. One is stable and another one is called as unstable. Understand? So how many isotopes we have? Isotopes are two types. What is that? Isotopes are two types. One is stable isotopes and another one is unstable isotopes. Okay. So now, observe very carefully. What do you mean by the stable and unstable means? So the isotopes which are unstable, remember, isotopes which are unstable, they are having a presence of extra neutrons. That is the main importance. So those who are having, remember, entirely the equal number of protons and equal number of neutrons, they are called as we can say like which are stable. The isotopes which are unstable due to the presence of extra neutrons in their nucleus. That is one. So if, for example, if we'll take only oxygen, what is the atomic number? Oxygen 8 and 16. So if we'll take 16, how many protons are there? One is 8 protons, another one is 8 neutrons. Now, if we'll go to the next one, how many is there? 8 and 17 means how many? 8 protons and
9
neutrons. So this is only called as instability. Understanding? So the isotopes which are unstable, whatever it is, so that due to the presence of extra neutrons in their nucleus, and they will emit various types of radiations, they are only called as radioactive isotopes, or we can say this radioactive isotopes also we can call as radioisotopes. What we used to call, guys? Radioisotopes. Now, if you notice it, as I told you, what do you mean by radiations, guys? Heat only. Yes or no? Yes? This heat, what kind of heat? Dangerous heat, which will cause us harmful to our body. For example, if we take radiations means, for example, such as alpha particles, beta particles, and gamma rays. These are called as one kind of light rays, which causes damage to our body. For example, if your bone is fractured, you might go to the hospital. They will take something called as X-ray. Have you remembered?
Yes, sir.
Sir.
Have you heard this word called as X-ray? Bone fractures and all, they will take X-rays. Yes, Samaya, Manya, Sai. So this X-rays is also called as one form of light. Understanding? But this is also causes cancer. Continuously taking more number of X-rays also causes chest cancer. So that is why we have to be very careful. Taking more number of X-rays also, it is not good for our health. So this is also one form of radiation only. So what do you mean by radiations means? The emitting of heat waves which are dangerous like X-rays, alpha rays, beta rays and gamma rays. So this is what we used to call as alpha, beta, gamma rays which are dangerous, or we used to say what? Radiations we used to say. Understand? So which is released by whom? Radioisotopes. Understand? So they are emitted by the unstable nuclei of the radioactive isotopes. So such a isotopes if we take, for example, carbon-14 isotope. That is the first isotope which is we will study radioactive isotope. Carbon-14. So carbon-14 means how much, Ra? Anybody? Carbon-614.
Carbon 614.
Number of protons are how many? 6. And number of neutrons are 8. What we used to call it as carbon-14 is the first isotope which we will study under radioactive isotope. Same way, if we take a lot of isotopes we have, one is arsenic 74, sodium 24, iodine 131, cobalt 16, and the most important and costliest one in the world is uranium 235. Understand everyone? What is that?
Uranium
Uranium
235.
Okay. Now recently you might be watch a movie called as Akanda, Telugu movie, Tamil dubbing also. Have you watched it? Akanda movie. Might be people. Uranium 235. So they used to do, people are used to get some kind of health disorders. Have you seen? Kids are getting bleeding, mouth bleeding and all, mouth and all blood is coming outside and they are getting some problem and they're dying. Have you noticed it? So uranium extraction mines is one of the dangerous mining in the world because uranium causes extremely large number of chemical reactions, uranium variations. In that also, uranium is having so many isotopes. One of the most prominent and most important isotope is what? Uranium 235. So this is the very, very dangerous and costliest metal in the world. 1 gram of uranium leads to huge millions of megawatts of power it can generate. That is why we are using this one in nuclear power plants. You might be heard nuclear power plants where the electricity is generated. There they will use it, this uranium 235. And uranium is one of the rarest metal in the world. It is used to present very deep inside the earth and very rarely it is available. So that is why extraction of uranium is also very complicated because highly reactive metal this is. And if you notice it, these uranium, 1,000 tons of soil if you will extract, you might be having a chances to get 1 gram of uranium 235. Do you understand what I'm saying? That much complicated process. And the extraction of uranium is $1 million question. Always need to invest crores of money to extract uranium. But present world, more people are running behind this extraction of uranium only, even governments also. For example, if you take Andhra, recently central government allotted 15,000 acres of Nallamalla forest to this extraction of uranium because there they have been found uranium mines inside the earth. But they have to cut a thick dark forest around 15,000 acres. So people protested and they have finally withdrawn the order because once the uranium mining started in a particular area, then the complete area surrounding minimum around 100 to 200 kilometer, it is going to destroy the agricultural lands and as well as people will born with the disorders. Crops won't grow, fruits and all, no plant will grow there. If you want the example, the best example, Google, you can go and browse just Pulvendala uranium extracting plant. Just if you browse and you can see the news stories which is coming. Even people are protesting from last 70 years to stop the uranium extracting there, but still governments to seek their benefits and all. They're extracting the uranium there. Kadapa uranium mines, you can search Pulvendala it is. So worst situation surrounding by the people, those who are living in the villages. Goat, even the babies of goat also born with the 3 legs. Humans will born with the half head. Half head is not developed. Only small hand is born. Like that, lot of disorders you can see how the fruits are changes into their like disorder, unhealthy fruits. Everything crops are not growing well, but still people are surviving there. Even government is not at all taking care of them anything. That much hugely damaged the atmosphere, this uranium. If it is inside the earth, nothing. If it is once it is exposed to the atmosphere, extremely dangerous, this uranium 235. Just I am saying you why it is, because future you might be entering to the mining so many, so that by the time you can understand. So these all are the examples of radioactive isotopes. We can say carbon 14, arsenic 74, sodium 24, iodine 131, and cobalt 60. So some of these are radioactive isotopes. So they will release. So why can't you say other? Because they must have high energy radiations emitted by these radioactive elements. Then only we can say they are called as radioisotopes. They must be capable to release very high level of heat energies. What is the heat energies? Radiations like alpha energies. Alpha rays,
Beta energy, gamma.
gamma rays. That is what you have to remember. So if we take here these high energy radiations emitted by radioactive isotopes, they are harmful to human beings itself. Understand? It will cause us cancers. I'm not joking. It will cause us cancers and lot of damages to our body and our environment. And imagine ourselves, we are the complex structures we are affecting means. What about the low level organisms? It will completely destroy them. Yes or no? That is why you can see every year millions of birds and species, they're going into the endangered list, and as well as completely extend from this earth because of our human activities only. So extracting uranium leads to extremely dangerous, and it is causes harmful to the human beings. So radioactive isotopes have to use it very, very carefully by taking a suitable precautions and at proper concentrations. Understanding, we have to use it to avoid the damage. If not, it may cause us to explode and may cause us to extremely dangerous to us also. So this is what. But even though they are very dangerous, we have applications of these radioactive isotopes. As I told you, uranium 235, one of the most important isotope, which will bombarded with the slow moving neutrons and heavy uranium nuclei, break up to form 2 small nucleus, and a tremendous amount of heat energy is produced. So that heat energy only used to boil water and big boilers to form steam. And that with that only they will produce what, guys? They will produce the electricity. That is what it is happening in nuclear power plant. So in nuclear power plant, they used to produce electricity by uranium 235. So uranium 235, a nucleus, number of neutrons are always bombarding each other. They bombard each other and will split into 2 small nucleus. The big nucleus will turn into small nucleus. So during the splitting, a huge amount of heat energy will release us. So that heat energy only will useful to what? Will useful to make the steam of water. Understand, Ra? Steam of water means in the sense of water vapor, to boil the water, and with the help of the steam, what they will do, Ra? They will generate the electricity. Understand? That is what means in the, but it will cause us, you might be see Japan having more nuclear power plant, and this all the power plants always they will install near to the water bodies. You might be notice it on the river beds or near to the ocean and all, because if it something goes wrong, if it will explode, hundreds of kilometers will be washed off. hundreds of kilometers, because that much extremely large amount of energy is used to releases. That is why Japan frequently used to get nuclear explosion, and it may causes to the floods also. You might be see tsunami and all. Even the completely it may destroy also. Even a single explosion will take place also. It may lead to around 70-80 kilometers will destroy. That much it is. So that this is what the importance of uranium-235, and this uranium-235 is one of the what isotope of uranium. Understanding? So uranium-239, uranium-270, like that different are there. So but importance of this isotope is most prominent one is uranium-235. So this uranium-235 nuclei are broken into smaller nuclei to obtain energy. That energy is only called as nuclear fission. What we used to call, guys? Nuclear
fission.
understanding means one big nucleus is going to split into how many nucleus? Small nucleus. So splitting up of this one big nucleus into small nucleus is only called as fission. What we used to call, Maitreyan? Darun? We used to call as fission. So that it is nucleus is splitting into two subnucleus. That is why it is called as nucleus fission. So what do you mean by fission? Means one big particle is breaking into two small particles. Then that is what we used to call as fission. Is it okay, guys? Yes. And same way fusion will take place. This is fission. Next fusion. Fusion means what? Small particles are combined together and they are forming big particle. That is what we used to call as fusion reaction. So fission, nuclear fission is different and nuclear fusion is different. So what do you mean by nuclear fission? A big nucleus is splitting into small nucleus. That is what we used to call as nuclear fission. So if you take the most, you might be heard about the atom bombs. Have you heard about the atom bombs or nuclear bombs? Hiroshima and Nagasaki, history. Maybe go.
Yes, sir.
Maybe go. Hiroshima and Nagasaki, they have been dropped two bombs. What is that bombs called as? Atom bombs. These atom bombs only also we can call as nuclear weapons, or we can say nuclear bombs. Yes or no? Please respond. Yes?
Yes, sir.
So these nuclear bombs, what they will use, they will use this uranium-235 only. What is the element they will use inside? Uranium-235. So that is why have you understand why the uranium is having much demand. Most of the countries, they will buy this uranium because to make the nuclear weapons. Understand? Or else you might be heard recently also stories, uranium-235, or else you can take plutonium-239. This is the two things, plutonium-239. These are the two things which we'll use in manufacturing atom bombs or nuclear bombs. Is it okay, guys? Everybody? Yes?
Yes, sir.
So,
Yes, sir.
the isotope. So, first important radioactive isotopes means which will release huge number of radiations like alpha, beta, and gamma, which will cause us damage to the human body. And we are having a lot of applications, so that we have to handle with carefully. The first application is what? We are using this isotope as a fuel in nuclear reactors of nuclear power plants for generating what? For generating electricity. Understand? That is the main thing. So in generating electricity, which isotope we are using? Uranium-235 is the fuel in the reactors of nuclear power plants for generating electricity. So like that, if we'll take next one. So the radioactive isotopes we can use as a tracers in the medicine to detect the presence of tumors. You might be heard cancer presence and all, it will form brain tumors. You might be seeing blood cancer, brain cancer, like the different cancers you are observing. Yes or no, guys?
Yes, sir.
So now these radioactive isotopes, if you take for example, you might be heard blood cancer. What do you mean by blood cancer? Anybody can explain? What do you mean by blood cancer? Manyan, Samya, Adarsh, and Tamil Selvan. Anyone? Alana, can you say what do you mean by blood cancer? Yes, Maitreyan. Maitreyan is not there. What happened to Maitreyan?
I'm there.
Maitreyan, are you there? I think who is missing then? Somebody left from the meeting. Yes. What do you mean by blood cancer? Anyone? Please, you might be heard already. Can anyone say what do you mean by blood cancer? Respond. What do you mean by blood cancer? So means inside our body, blood is not transforming properly. Somewhere it is clotted, means like a solid it is used to form. That is what we used to call as blood cancer. Understand everyone? That is only you might be heard in biology called as leukemia. Have you heard? No one will say.
No,
No,
sir.
sir.
So leukemia, blood cancer we used to say. So if you notice it here, this formation of a solid understanding, these are clotted blood inside the nerves or arteries. This is what we used to call as tumors. Even brain tumor, you may be heard. Brain tumor is the one, or else brain dead is the common disease you might be seeing nowadays. Most popularly, so many people are affecting with this. Brain tumors means inside the brain, the blood will clot. That is what we used to call as brain tumor. So, in which part of our body this tumors is forming, or else and blood clot is taking place? That is what we can find with the help of radioactive isotopes. Means we will use as a tracers. Understand, like a detecting where it is present, like a bomb tracers. Bomb detectors. We can use it. Correct. Scanning.
Yes, sir.
It will
Yes,
detect.
sir.
Like that. We'll use this radioactive isotopes as a tracers to detect what? To detect tumors and as well as blood clotting inside a human body. You understanding? So blood clotting in human body. Sir, which isotope we can use? If we'll take arsenic 74 is the most important tracer, is used to detect the presence of tumor, and as well as sodium 24 is used for detect the presence of blood clot. So that is you have to remember. So arsenic 74 we can use to find what? Arsenic 74 for tumors detection, and same way sodium 24 we can use for detecting blood clots. Is it okay, guys? So general awareness also it is very important. So what is that? Sodium arsenic 74 for tracing detecting of presence of tumors, and sodium 24 we use it for presence of blood clot. Okay. So now here we will use our instrument here to exact position of this accumulated radioactive tracer. We can find with the help of a device. The device is only called as Geiger counter. Understanding? Actually, it is G. It will start with the Geiger. So we can say Geiger counter also. So the mission which we'll use to detect this radioactive element where it is found. Understanding? So like a tracing where it is going inside our body, like a GPS tracking. So that mission name called as Geiger counter. What we used to call? Geiger counter. Okay. So which is used to found tracing of tracer. Understand? Tracing of tracer, like a GPS tracking. We can follow correct where the person is moving. We can able to notice it correct while you are moving. So while you are moving on the road, where you are, here or here, we can find with the help of this mission. That is what a tracer we can find with the help of this mission. The exact position of accumulated radioactive tracer we can find with this. That mission is called as Geiger counter. So this is what the second important. Next. Treat cancer. You might be heard the cancer. Yes or no, guys? You might be even senior actors. Most of them they are affected with the cancer. You might be see they are going to foreign. They are going to take this medicine. 7 stages cancer treatment. Like there's so many things you might be heard. Correct. So in cancer treatment also we are using one of the isotope that is only cobalt 60. Understanding? So this cobalt 60 is the radioisotope used to cure cancer. That is the third importance. So we are using in what? Treatment of cancer. Okay. Treatment of cancer. So which one we are using, guys? Cobalt 60. So if we'll take here, this cobalt 60 is the radioisotopes which are directed to the cancerous tumor in the human body, and this cancerous collects get burnt, means it will start blast, so that the treatment of cancer by using radioactive radiations is called, that is only you might be heard called as radiotherapy. You might be heard in news also. Recently, one of the Tamil heroine, what is her name? I don't know. I'm not Mamata Mohandas. You might be watching some movies also. Mamata
Yes, sir.
Mohan. Yes. So she is also a cancer patient. And recently Hamsa Nandini, you may be heard. Some movies she may watch. She may act in Tamil also. Hamsa Nandini. She also affected with breast cancer recently. So most of the cancers, you can see what they will do. They will go for a treatment called as radiotherapy. Understand? So radiotherapy. What do you mean by this radiotherapy? Means they will send this cobalt 60 radio. Understand? So this radiotherapy, the same thing, cobalt 60 they will send, and they will collect the tumor wherever it is there in our body. They will make that tumor, means what it is, some kind of a solid, SR Nora, some kind of a solid substances, means the cells are become inactive, they're dead. Usually cancer means